Homework 11, section 6.1, discrete random variables, video 10. In the previous video, we had a formula for calculating variance, and it was a little ugly, but there's an equivalent formula for calculating variance that, in my opinion, is less ugly. Why is it less ugly? Because instead of doing the squares of a bunch of subtraction problems, you only do one subtraction problem. And that sounds kind of minor, but I'll let you be the judge. The other formula for variance, remember the variable for variance is sigma squared, and we're subscripting it with an x to allude to the fact that we're finding the variance for a random variable. It's still a sum, but this time the sum is just the square of each x times its probability. And you may be saying, well, where's the subtraction problem? Well, the subtraction problem occurs after you do all this. It's just one subtraction problem. All you do is subtract the square of the mean. So if we did that for this one, the setup would look like this. First, do the sum. Square each x times its probability. So 0 squared times 0.125 plus 1 squared times 0.375 plus 2 squared times 0.375 plus 3 squared times 0.125. So the sum's a little bit easier to set up, and we just do one subtraction problem. We subtract the square of the mean, which was 1.5. So I'm going to go ahead and put this in the calculator just to verify that we get the same value as before, which I believe was 0.75. In fact, I'm not even going to mess with this term. It's times 0. It's going to equal 0. It disappears. The second term, I don't have to worry about the 1 squared. It's 1. 1 times anything is itself. So I can really streamline this. Don't need that. Don't need the 1. But I do need the 0.375 plus 4 times this plus 9 times this minus 1.5 squared, and I get the exact same answer. And it was a lot easier to put in the calculator, even if I had to put all of this in here. If the numbers weren't easy to square, then I would have to work a little bit more. But in this case, they were easy, and I took advantage of it. So the variance does end up being the same, 0.75. Personally, I think this formula is easier because these individual parts of the addition problem are quicker to calculate. They don't involve subtraction problems getting squared, and there's only one subtraction problem at the end. So whichever one you think is best is the one that you should use. I recommend the second one.